Yeah, fine tuning is dead. Long live fine tuning. The idea of this talk came, I think, mostly from just like some fun tweets. I tend to believe that fine tuning is less important than it once was, and Hamel challenged me to like actually defend that take, and so that's what I'll try to do here. All right, so who am I? So I'm Emmanuel is my name. I've been doing ML for gosh, almost 10 years now. I was doing data science originally, then I worked in ML education actually. So trained models for demand prediction and data science, helped people train models in ML education. I wrote a practical guide on how to train ML models. Then I worked as a staff ML engineer at Stripe, where I trained more models. And now I work at Anthropic, where I fine-tune some models, and also currently I'm helping out with efforts to actually understand how these models work. Very
And
important.
just to plug you a little bit more,
Yeah,
because I just think you're a little bit humble. It's like there's a website, mlpower.com, and you can like see Emmanuel's book. It's a classic in machine learning and like I would say in applied machine learning. So definitely check it out.
I appreciate the plug. Yeah, check it out. I one day hope to update it with some LLM specific tips. It's just general machine learning knowledge for now. And yeah, you can get the first chapter for free on that website. So um, no commitment if you hate it. This is like the most important slide of the talk. This talk is my opinion, not Anthropic's. Mainly, I say this because Anthropic, like among other things, offers fine tuning. So if they thought fine tuning were dead, that wouldn't really make sense. And so this is mostly like, kind of yeah, like hot takes and beliefs based on just seeing the field evolve over my career, rather than anything that like Anthropic really believes. So I've been training models for 10 years. I don't recommend it. This is I don't know. This is like really the talk in two slides. I think it kind of sucks for a variety of reasons. And if you've talked to enough people that like do it a lot, as I'm sure a lot of you do, they'll tell you all of the horror stories that come with it. I kind of want to talk about three things though. We'll talk about the horror stories in the third part, actually, in the difficulty. But one, I wanted to see like trends I've observed over the past, let's say, 10 years. Then like kind of some performance observations on the fine tuning work that I've seen shared or like various papers, and then we'll talk about the difficulty. So first, trends. So I think that like in machine learning, the best way to kind of have a lot of impact is to just be afraid of anything that sounds cool. Like anytime in my career, when there's been anything that sounded like the cool thing to do, it tended to be the case that like if you did that, actually that was like vaporware, and really you should be doing the boring stuff. And so what that means is like, in like 2009, maybe like people were like, oh my God, machine learning is like a big applied thing now. We want to train models. But really, like if you look at like delivering value, really what you needed is like data analysts and data scientists that like write good SQL queries. And so that's what you should spend your time on, even though it sounded less cool to people at the time. In many places, this is still true today. Fast forward to 2012, like the deep learning revolution, maybe it's a bit early, 2012, 2014, let's say. Everybody wanted to use deep learning. It's like, oh, you had like startups that were doing, like, I don't know, like fraud prediction that were using some random forest that were like, surely now we need to use deep learning. Actually, like that was too early. At that time, it was very, very hard to get deep learning models to work. You should just use XGBoost. Do the boring thing. 2015, it's like now deep learning is in full swing. There's a bunch of papers, like the exponential is starting. Surely, like what you want to do is invent a new loss function or like improve on like the theory of an optimizer. But really, like if you want to actually make your model better in practice, you just want to like clean your data set, notice the obvious errors, fix them, and then that would get like about 10 times larger improvement in about a tenth of the effort. And I think in 2023, we have a similar thing in a way with like definitely training your own foundation models. In some cases, I think, and then also just fine tuning. It's very appealing. It sounds very cool. As far as I can tell, it's actually rarely the like first thing you should reach for or the most useful thing you should go for. So I think just based on priors, we should be suspicious of fine tuning because it sounds like the coolest thing. And that like right away, you're like, it's the coolest thing, probably gonna be the worst use of my time. I made a little chart that I think illustrates this somewhat. Oh no, hold on, fine tune an LM. Yeah, okay, same thing. We talked about this already. I made a little chart. Um, this beautifully drawn chart is like my take on sort of like if you're doing machine learning in a practical way, So like, what was the way to, best leverage your time? And so at the start, hopefully you can see my mouse, but at the start, people just trained models. There was no fine tuning because there were sort of like no models to take and to fine tune, or at least it was like, exceedingly rare. And so you trained your own like random forest or your own like SVM or your own whatever, like even your like MLP, and that was that. And then kind of with not really when ImageNet came out, but like a few years after with like VGG and then later on ResNets, that's when sort of like fine tuning I think became a thing that a lot more people started to pay attention to. You could take a pre-trained model on, in these cases, they were image models. You could take a pre-trained model and then like fine tune it on your smaller data set for cheaper and get something that was better than if you trained it from scratch. And so as time went on, that became like more useful. I think BERT was also a maybe like big moment where that started becoming useful for text as well, where you could like fine tune BERT models or fine tune other models. And so I would say that like there's like this general trend that like okay, like fewer people are training, more people are fine tuning, and then around GPT-3, maybe a little after because it took time for people to sort of like really pick up. Uh, you know, there was this sort of like concept of like do you even need to do like any backwards pass on your data at all? You could just maybe like take the model and maybe it just works, right? That's sort of like I would say that concept is like the original promise of LLMs, right? Is that like you actually don't need to train, they learn in context. You can just prompt them. And so I like this chart because it's sort of like, well, I don't know if fine tuning is dead. I don't know if like it was just a blip or if like this chart will like kind of like go back up in prevalence. But I at least like the sort of like trends of like, it used to be that really there was nothing else you could do than training, and or at some point you could like replace your training with fine tuning. And now there's this whole other categories of applications where actually you don't need to do any training at all. And so the question is like, how do you extrapolate that trend? And I think like the realistic, not fun, not hot take answer is nobody knows. But my hot take is that line goes up, and so I think we're going to keep having that orange line increase in the future. Maybe I'll pause like really briefly in case there's questions because after that,
To state the semi-obvious,
yeah,
if we go back to your slides about like what not to do,
yes,
most things that you said not to do, they were the thing to do a few years later. So you're like, oh, don't train ML models. And then a few years later, you're like, yes, you should be using XGBoost. And then you're saying don't do deep learning. But then I think the thing after this is like, you're saying like by 20, at some point later, you say
yeah, yeah,
you
yeah.
should
I don't
do
think we
that.
have
Does
used
that
deep
mean that if you say not to train, that you shouldn't fine
learning.
tune now, that it's going to be the hot thing in a few, it's going to be worthwhile in a few years?
I mean, I think like that. I don't know, right? Maybe I think this is not true for all of them. Like notably, like I think invent a new loss function is still like not a thing that you should do.
Mhm.
Even like almost 10 years later or something.
Okay.
So I think it depends. I think it's certainly the case that like as soon as something comes up, like deep learning, people want to do it, and sometimes it will actually be useful, sometimes it'll not be, and it's hard when it first comes out to know whether it'll be like the invent a new loss function category or they use deep learning. Um,
Let me
yeah.
let me ask a couple of questions from the chat.
Yes.
We got one from some Simon Willison guy. I get the
Okay.
argument for not fine-tuning LMs, but how about embedding models? Is there a relatively easy value to be had from, for example, fine-tuning an embedding model on a few thousand blog articles to get better quality semantic search?
I think that's interesting. I feel like to me that's a similar question to fine tuning a model. Like I feel like if you buy that these models are getting better, um, and that we're gonna like I think right now we're focused a lot on improving the LLMs rather than the embedding models. Like comparatively, there's not that much activity in the like embedding provider space. But if you buy that they're going to be better, um, I feel like you'll just have like very general embeddings that work well. I think where this gets tricky and where you might like always need fine tuning or need like a different paradigm entirely is like, your company has like a product that's like the XS23 and like nobody knows about it like outside of your company or something. And you want to build like search based only on embeddings with this. I think like that might require either like some fine tuning or some like embedding or some like combined RAG, like which honestly is like what I've seen work really well, right? Where you do like a combined sort of like some keyword search, like and some embedding search.
And then there's a
What about the case where like okay with RAG and retrieval in the domain specific case, like a lot of times what people think is a good sort of ranking or retrieval can be very like specific, you know? It can be hard to like capture that in an embedding, no matter how good the embedding is. Um, so do
Good
you think,
example.
yeah, like that's the part that yeah, that's the part I wonder about the most.
Yeah. I think like, not to like add spoilers or anything, but I think at the end of the talk, like I have this like where like I think that fine tuning is dead is like the hot take version. I think that like the realistic like thing that I believe could happen is like fine tuning is 5% of the ARR versus like 50 or something. And so I think it's totally possible that you can imagine that like yeah like for your very specific search where well I think it's complicated because like this is kind of getting into what I talk about later, but as these models get better, you can imagine them just being able to like in context understand like what your specific search is. And so like, you could have like your LLM drive your search and like do some sort of like basically like query expansion just because it like really understands well the context. For like pure embeddings, I don't know. Yeah, it's possible that you always like would need to like fine tune some embeddings for some retrieval.
Is there any benchmarks or data comparisons, the Dimitri SS, that compare how good your results are from doing a better job of prompting versus fine tuning?
Yeah, there are some. I have some later in the talk. I don't have actually like I have like RAG versus fine tuning, which is kind of similar. I would imagine like prompting to sort of like be a little worse maybe than RAG. Actually, that depends. Maybe like comparable to RAG. So I have some. I looked up some of the papers I could find that I'll share after in the next section.
Great.
Cool. Um, Yeah, so I'll say that like I'm also all ears if people here have like papers that are comparing this performance. I was surprised to like not find that much. I'm gonna be completely honest. I didn't spend super long doing literature review, but I spent like 15 to 30 minutes looking for a bunch of papers I could find on this that I was in addition to ones that I was always already aware of, and I didn't find that much that I found was super informative. Um, so this is an example, I think, from the OpenAI forum of like fine-tuning GPT-3 that is like one of the first examples when you look at like fine-tuning versus RAG, at least that I could find. And like I think is relatively illustrative of like what happens in some cases, not all of them, obviously. But in this one, you have like you have the base model, and this one, the fine-tune, I think, is like I had it as start because I think it's like the worst case scenario or something because it doesn't seem to be doing any better. And then you have like context injection, which I think is like basically RAG, if I remember well from reading the post, and then like various different models. And so, it's the case that sometimes fine tuning doesn't work.
I have a question about this
Mhm.
that maybe you can help me understand. So I always see these kind of things about like fine tuning versus RAG. And then I get really confused because my fine tuning always includes RAG, like
Yeah,
includes examples of RAG. And I'm like, what do you mean fine tuning versus RAG? It's not like it's not a versus thing. It's like you
yeah,
do both.
yeah.
Uh,
Agreed. I have. Can I just say like I'll answer this in like 2 slides?
yeah. Okay,
Okay.
good.
Yeah. Agreed with you though. Well, okay. Maybe actually the one thing I'll answer. So in 2 slides, I have like a comparison, like including fine tuning, RAG, and both. But the other thing I'll say is like I think that this is also a matter, like one of the reasons why this is a hot take I have is that I think it's also a matter of prioritization. Like, if you're like at this point in your life or something and you have the choice between fine tuning and RAG, I think it's very important to know like, okay, like which one's gonna be harder and like which one's gonna give me the biggest lift. And then like, of course you can always do both, right? But still like if there's two options, you kind of want to know which one is the most efficient anyways.
Oh, yeah, that makes sense. Definitely agree with that too. Like you
Yeah.
should do RAG first.
Yeah. Yeah, I feel like this. Yeah. Anyways, I would bet that like at the end of this talk, we're like, actually, we agree on most things, but it's you gotta have a few outtakes. This is okay. So I think this is yeah, exactly. Okay, so this is kind of I said in 2 slides, but this is basically what you're asking me about. Um, this was a paper. I link it here. Kind of like comparing fine tuning and RAG. It's like on relatively old models. The paper after has like more recent models, but as far as I can tell, that trend like actually like held. And this is kind of hard to read, but basically, you have like this is your baseline, you haven't done anything. This is you just do RAG. This is you just do fine tuning. And this is you do fine tuning plus RAG. And then I would like just ignore the sort of like, this is like, do you do like some LoRa or do you do like some like full fine tuning? And then I think this is like, I don't recall. These are like different prompting methodologies if I remember well. But or yeah, this is like the like fine tuning data set that you use. Like, is it formatted as a question answering pair? Anyways, you find that like if you look at all of these models, like really like the increase comes like mostly from RAG. Like notably, this is even more true for the larger models, where like you get 58 with RAG, and with fine tuning plus RAG you get 61, and with fine tuning alone you get like way less. This is less true for the small model, right, where you get like a bit like quite a bit more with like fine tuning plus RAG. But if you look at that trend, especially for like base and large, basically like you've gotten almost all of your benefits from like RAG, and it is technically true to say like if you do fine tuning, you'll get like more benefits, but you'll go from 63.13 to 63.29 as opposed to like a 10x. Well, going from 6.7 to 63.
So I think it's worth stopping here because I think this is actually a very confusing. Like people get stuck on this. Like, um, I'm of the mindset like, hey, if your model needs context from your data, you should always do RAG. Like, you don't want to try to fine tune all of that knowledge, like, from all your documents and everything. Like, try to like expect that your model is gonna like memorize all of that and stuff. I don't think it's a good idea. Um, So I feel like I feel like if your application could use RAG, you should do RAG. Like there's no
Yeah,
I think people get confused. Like when they see papers like this, like, oh, fine tuning versus RAG, like, oh, maybe, they're like, I'm like,
totally.
no, there's no option. You have to use RAG.
Well,
I mean, like in most applied situations, like to make it work.
I think this is sort of like, this is why like you doing this course is good though, because I don't think this is common knowledge. Like in particular, the like, like maybe you other practitioners that I've talked to, like some people know or have the like intuition, which I think is correct, that like fine tuning isn't really the right solution if you want to like add knowledge. Like it's like that's just not what it's for in most cases. And so like, like, yeah, you can like say like, for this use case, actually, it makes a little sense. For that one, maybe a little bit more. But I actually think that that's not well known. And so like one of the reasons that I'm like on this hobby horse or something is to be like, no, like in most cases, like you're like, like my problem is that, like this model doesn't know about whatever our business model is. And it's like, yeah, the solution for that is not fine tuning. Usually it's like, just tell it what your business model is. Um, so yeah.
Makes sense. Yeah.
Um, I think I have, yeah, this is similar. I found this paper that was doing some like, yeah, again, like RAG plus fine tuning, not to like belabor the point, but like, I think I was curious on like one thing that I was curious about is like, okay, like, I think there's probably like a model size thing going on. Um, like anecdotally, like I think there's like some papers and some like, like various experiments that I've been running where it seems like fine tuning is like more beneficial in like smaller models than bigger ones potentially. And so I thought it was interesting to find that this paper was like doing this with small models, smallish models. Um, and I think like this is another example of what we're talking about, right? Where like I don't remember what the use case is for this, but it's like for knowledge. And so it's like, yeah, for knowledge, even for small models, like you want RAG.
And so how do you interpret this table? Like the ones on the very right-hand side, the FT RAG plus RAG, does that mean it's getting worse with fine
Yeah,
tuning and RAG?
that's
Like
how I interpret it. I
that's a
think
little bit surprising, yeah.
my interpretation is that this is within like the noise. Like I would like guess like just based on like base plus fine tune being like pretty close, slash even like worse here and like pretty close, that this is just like base model and fine tune in this example, like your fine tune doesn't do much. And like I wouldn't over index on this being like slightly lower. Basically, I'd say like, yeah, fine tune plus RAG probably just does as well as like RAG would be my
Hmm.
hunch.
It's interesting to look at this without reading the paper because we don't know what task is being scored, or at least I can't tell. And then it's like, if you wanted it to measure adherence to a writing style book, then I suspect RAG doesn't do so much for you. Like if it's just writing style and fine
Mm-hmm.
tuning, like I think, right, we could pick a task and then tell any story, get the results to tell any story we want, but it's
Yeah,
just a matter of what task are we optimizing for.
totally. Okay, so I think this is a great point because as I was doing this and I was like writing my slides and like giving like a diabolical laugh, being like ha 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 ha, like RAG is beating fine tuning or whatever. I was like, well, okay, I should like do a search for like papers that show fine tuning beating RAG, and I didn't find many examples. And I think like a lot of the examples that I've seen are like Twitter threads or something. And so, anyways, this is like mostly a call for like either like the host of this workshop or like anybody that's attending, if you have like good papers that show this for like like what you're talking about, like style examples or thing that fine tuning is more suited for, please send them my way because I
I
would
think
like.
it's hard to explain because like even when I try to explain knowledge, uh, like hey, fine tuning is not good for adding knowledge.
Mhm.
Like that word is not fine-grained enough. Like, what do you mean adding knowledge? Like there's certain
Agreed.
kind of knowledge that does make sense. Like, and they're like, oh, what kind of knowledge? And I'm like, oh, okay. Like I get really, becomes an intuition, but
Yes.
like I haven't expressed the intuition like completely clearly as much as I want to.
Well, and my like maybe like scaling pill or whatever like hot take is that this intuition or like the boundary between those changes with every model generation. And so it like maybe like a good example is like I think it used to be the case that like like you could say like learning like a style of speaking or something is something that requires fine like some like style, not knowledge, like way of saying things requires fine tuning. But like the better models, the like more recent ones, can learn like a style from like a two-line prompt, which the older models can't do. And so like for that, it's like less true. But there's still other things where like maybe it makes more sense. And so I think that like adds to the concept like what is knowledge is something that changes with every model generation basically.
Yeah,
Yeah, no, that makes sense. I have that same experience as well.
I
Yeah,
suspect there are a bunch of cases where we could like look at it and we'd be like, we're not even sure if that counts as style or content. So if we were the fine-tuned on manufacturing copy from the makers of like the XS32 widget, and everywhere when it says like the best widget is, and then you fill in the blank, it's always XS32. Like that's sort of knowledge. That's knowledge that XS32 is some great widget, but actually it's just, well, that's whenever they express positive emotion, that's like the widget that they express it about. And so it's sort of tone, and
yeah.
maybe knowledge is actually like not a very clear abstraction.
Yeah. I mean, notably, like this is like way outside of the bounds of this presentation or something, but like it's not clear from even like the early work that we have in like interpreting these models that like the concept of knowledge as we're discussing it here like is something separate from the concept of style within their actual weights, right? Like I would bet that for many cases it isn't. And so it's not like there's like like that kind of like thing that's in it in like this like attention head or whatever like is the knowledge versus something else. Like I think it's even the model doesn't have like that clean separation.
We've got our first audience question. You want to go ahead, Ian?
Yeah, sure. Hi, thanks for this talk. So
Yeah.
my company, we have a very complex knowledge base that we've curated, like 100,000 hours, I bet, of time for precision oncology, which is genomics and cancer. My intuition is that I'm going to be able to curate, using those curated rules, a fine-tuned model that does a good job at creating a first draft of a curation, right? So we curate what are called guidelines and clinical trial documents. Does that fit in your model? What would be your advice based on that description?
Oh boy. I think the part that's hard, just going back on what Hamon was talking about, is that as a non-expert in this domain, I think I have a worse intuition than you do on like where this falls on the like knowledge versus style spectrum or something. I I think one comparison I would draw here is like maybe the actually I talk about it in the next slide, but there's like some attempts by like people to train sort of like LLMs that are specific to finance or to agriculture or whatever, and those often like in the short term beat the current open models or current available models, but then I have an example after they often are just beaten by like the next bigger smarter model. So I think that's one thing I would consider is sort of like what's the trend of maybe if you take like the Claude 3 models or like the GPT models and you take like the smartest and the dumbest one and like you see how they compare with no fine tuning, that could give you a hunch of like the next generation is probably actually going to be good enough. Um, and then the other thing that I like to use to like decide whether fine tuning will help or has a chance to help, and also whether I need it at all, is like to just keep adding a bunch of examples to my prompts of like basically the shape of what I would fine tune on. I feel like probably other people have said this in this conference or something, but like that seeing how well model performance increases with that also like can give you a hunch of like how well it would increase with like fine tuning on a large data set. And notably, if you see it plateau after a while, you don't need to fine tune, in my opinion.
We have a
You
related
see it
question
plateau
actually
above what you
from,
need.
oh, sorry. We have a related question from Simon Willison, who asks, does fine tuning ever work for adding knowledge? I see this question come up all the time. And I think like the thing that's like confusing about answering this question is like there's some knowledge that is like kind of intrinsic to like maybe like a world model or something. Like I think about like, okay, this could be wrong, but like a physics constant of like gravity of the earth or whatever. Like it's like you I think it's like for my intuition tells me a language model is okay with memorizing that. I've seen that like so many times. I don't want to retrieve that with RAG. But like something more specific about Hamel, like about my life, like changing facts, okay, that makes sense. Like something like, that is not trained on clearly RAG. But there's like some middle grounds, a fuzzy middle ground where I have strong intuitions. But I don't know how to like tell people like about adding knowledge, like what is, yeah, like I understand like intuitively, like there's some knowledge I want the language model to internally like grok, like
Yeah.
fundamentals about the world or in things, but like others, like I would never expect it to like, internalize. So I don't know, like, how do you explain this aspect?
Yeah, I think it's also complicated, right? Because like I think for most, so the first thing I'll say is like for most things where like I want to add knowledge. So let's say I want to add knowledge to like some model, that I don't know, like I like strawberries or whatever. So when it sees my name, it like knows that like, oh, by the way, like Emmanuel likes strawberries. Um, I think that like first of all, that's almost always something that you could just do with like a prompt, right? Or like some RAG or whatever. It's like, oh, when there's like a question about me, like we retrieve something and there's like, description about Emmanuel, like he likes strawberries. And if you have a good instruction following model, it'll just do the same thing. And so then the question is like, okay, like if I was to like change the weights of the model for it to do this, like how do I do that? And I think this is like often actually like not that trivial because if you just like fine tune on a bunch of prompts that are like, what does Emmanuel like? He likes strawberries. If you have like a dumb model, it'll only tell you that I like strawberries if you ask it what I like. But oftentimes what you want with your fine tuning is you want it to like know this information and use it when it's relevant in other contexts. And so maybe then you have to like think about like, like what I want to fine tune is like, I don't know, like we're a business that does like shopping recommendations. And so when like Emmanuel logs in, like, and he just asks random questions, I'm just gonna like be like, oh, like by the way, like did you buy your strawberries this week or something? And like you fine tune on like these specific prompts for this specific context. And then I guess my qualm with this and calling it like knowledge, like, are you adding knowledge to the model? Or are you like basically fitting it so that like in this narrow distribution of these few prompts that you've given, it leans more towards like mentioning strawberries. And I think this like gets at like fundamentally like how these models learn. And at least as far as I know, we don't actually have like a satisfying answer to this. But I'm pretty convinced that like a lot of fine tuning ends up in that like surface level realm of, like in this specific context for this specific question, shaped like the fine tuning data set, I will like tell you this thing versus like I've now learned whatever that means for a model that like Emmanuel likes strawberries. Hopefully that made sense.
Yeah, no, I think there's no right wrong answer, I don't think.
I think the answer to a lot of this stuff and the reason why it's so fun to work on is that we don't know. And hopefully you find out soon. But yeah. I have a few examples
Emmanuel,
oh yeah, go ahead.
oh, do you have a second for another question?
Yeah.
Great. So in terms of knowledge, okay, so one of the examples that I feel like perhaps has worked out that I've heard about is, so if you take like multilingual models and if those are not highly trained on non-English, but they have some non-English of the other types, and then so it sort of understands, a little bit of that language, but in general, its quality on the non-English languages is kind of crap. If you then fine tune a lot more on the other language you want to get better quality on, that tends to work. And it seems like it's sort of like giving it new knowledge, but it's not like it already knew some of that language. It was just kind of crap at it because it didn't have a lot of examples. Is that maybe a case where that makes sense?
Yeah. I think that's interesting. The first thing that this brings to mind is that like in some of the interoperability work that we've shared, like if you look at some of the way that the model represents, like at least large competent models represent various things, like kind of like the concept of a table or you know, like whatever, like the Golden Gate Bridge. Um, it'll represent it in the same way in different languages, and this is like increasingly true as the model gets smarter or something. And so I could buy that, like fine tuning that to be better is like slightly easier than other types of fine tuning because it's already seen this. It's already kind of like learned to map different languages to like a concept for other concepts, and so it like needs a relatively small change to like map, um, you know, this like new concept that it somehow like hasn't really learned fully for this new language, um, to be the same, like basically part of the model that does the reflection for it in English. So I don't know, like I could see that work. Um,
Right.
for the
Like,
specific thing. Oh, sorry, go ahead.
no. And so similarly, like, do you think that is the similar kind of thing that happens when people make, fine-tuned code models that are good at doing software, programming, essentially? Or would you think that's a different
Yeah, I think with
thing
fine-tuning
happening?
models, there's like a bunch of other concerns of like it depends kind of what you want. But if you want like a like code complete, this is like the style we were talking about, right? You kind of want the model to like not, it's not going to be like, oh hi, like I'm Claude, let me tell you about code. You just want it to like autocomplete the current line you're writing, which I think like that was like the style discussion we were talking about. And then there's like speed concerns as well with code language. I think that like the knowledge of your code base actually like that's also something that RAG works really well at, and I'm not sure you need like fine tuning for, right? Like just like even having the good context of like what you're currently working on. Like I'm not convinced, maybe to be clear, that like I don't think there's good data on this. This is my hot take, but I'm not convinced like fine tuning on your whole code base or something like gives huge gains compared to like putting as much of that code base in the context. Um, the other thing I'll add that's related to this is that like, you know, both I think for like Google's one of Google's launches recently, and then like for the Claude 3 launches, there was like an example that was shared of like a model not knowing one of a rare language, and then you put I think like 100 pages of that language in the context, and then all of a sudden it can do it, sort of like without any fine tuning. And the reason I mention it is like I think the fact that this is comparable to fine tuning is like really interesting, and I'll talk about it a bit more after, a bit more why I think it's very interesting. Okay, I'm going to jump ahead. Feel free to interrupt me if I haven't answered your question properly or if you have other ones. This is basically what Hama was saying. Fine tuning is not the solution for domain knowledge. This was the other paper I mentioned, which is I think this is an agriculture paper. And you know, it's like if you fine tune like GPT-4, you get 61% performance. If you do that and you do RAG, and if you just do RAG, you get 60%. So again, like you know, strictly if you really care about that 1%, useful, but really you got most of it from RAG. And also like I don't know how big the error bars are here. But this is kind of confirming what we were saying, which is like this is like a domain knowledge kind of thing, and so it feels less useful. Right. So the other thing that's I think is challenging for fine tuning, especially if it's like at the cutting edge, is that you're aiming at a moving target. You know, like there's many labs, Anthropic among them, that are like continuously working on making the model better. And so this example is like the Bloomberg GPT example. I'm realizing here, I apologize. I think I've like used a bad figure, but essentially the Bloomberg GPT model claims that it was doing better than ChatGPT at the time or GPT-3 on like some financial analysis task, and they like pre-trained their own model. So it's not fine tuning, it's pre-training here, which I guess like doesn't show really in this table. But then I think like 6 months later, you know, GPT-4 came out and ChatGPT, and it was just way better than like their fine-tuned model at basically everything.
So I
And
have a
think
question
like,
about this. That's a really interesting. I'm glad you brought this up. Like, um, first of all, the Bloomberg example, like when they made a big deal out of it, like, hey, we did this like pre-training of this model. It costs like millions of dollars,
yeah,
whatever. My first reaction was like, why did you pre-train a model? Like, and why
yeah,
didn't you fine-tune a model? But that's a different question. Second one is like, I'm curious, like, okay, yeah, these frontier models or whatever you want to call them, they're like getting better. Like you're saying, it's a moving target. If you have a fine-tuning pipeline, let's say one for like Claude, just just because I don't want to call attention to OpenAI, just to keep it so don't get kicked out. It's like if you have a good fine-tuning pipeline where you have like you're fine-tuning these like even big models, can't you just keep moving with the state of the art? Like, hey, okay, this new model came out, let me fine-tune that and let me keep fine-tuning that. Assuming that those APIs are exposed. Yeah, like for the most powerful models, maybe they're not exposed yet, but just
Yeah.
curious.
I mean, like, I think like the question is, like, can you always take the latest model and fine tune on it? I think the answer is yes. Although, like, obviously, if like if you take the Bloomberg GPT example, they pre-trained, right? But like, presumably, the whole point of their exercise was like that it's a large data set that they have. So the cost to fine tune isn't like much cheaper because they probably like mostly train on their data set. And so it's like, do you want to pay that much money anytime there's a new model that that appears? Like that can often be sort of like, like you could either, if you have like a pipeline that just takes an arbitrary model, like does some RAG and some prompting, you can swap models easily. But if you like have to like refine tune, that gets pretty heavy. So I think it's possible, but it's just a matter of cost. And then the other thing, like on that note, is um, like I think that like the fine tuning of like a larger and larger model seems, and I'm curious, maybe you have like more experience on this. I tried to find some papers, but like that's mostly like an anecdote. Seems like less and less effective or something, or it seems like as these models just like get better,
Hmm.
they just get better at everything, and then like
Yeah, okay, so the kind of the most common tactic is to use the data generated by like the most powerful model to train like the one that's like the faster model, like one step below it,
yeah,
and keep walking that ladder up. Like,
yeah,
okay, new model came out. Okay, let's use that, get better data, and like whatever. And like, of course, analyze the gap, but it's usually like, okay, you get a much faster model, uh, and hopefully similar performance or better performance.
I guess like
But like, yeah, you have to like look at the cost because there's probably like some you have to do the analysis. Like, does this even make sense? This exercise?
yeah, exactly. I think that a lot of, at least as far as I can tell, like a lot of teams, companies are like underestimating the cost and overestimating the value of this stuff. But yeah, I think you certainly can. Again, I'd love to like. I wish there were like a few more examples of what we're talking about. Where it's like I haven't seen many papers where it's like we do this and we train like this super small model and it like actually works better. I think I've seen this like for some like evals that seem like obviously overfit to in some examples where then like the model doesn't generalize and so it's like nice for a paper, but can you actually use it for anything useful is not clear to me. Um, but yeah, you can do it. I mean, I think it's a matter of cost at this point, right? And of like value. I think there's like certain use cases where it totally makes sense. I think there's certain use cases where it's like pretty far down the priority list, in my opinion.
Makes
Um,
sense.
I have. Oh no, yeah, this is what we're talking about. Okay, so unless there's any questions, I think this is basically what we're talking about, and I'll just dive into the difficulty.
Yeah, please.
So this is something that like I feel like Hamel, you've made like the same graph, or like at least we've talked about this exactly. Where it's like really like for like when you're doing ML, like the optimal use of your time, like even if you're doing fine tuning, to be clear, even if you're training models from scratch, is usually like 80% data work, collect it, label it, enrich it, clean it, get more of it, see how it's broken. You know, 18%, let's say, just like general engineering, like how do you serve your model, how do you monitor your model, how do you make sure that like it works, there's no drift, all that sort of stuff. And then like maybe like 2% debugging some like my model doesn't train, or I get a GPU or something like that. And then like you're like kind of like 0% usually like cool architecture research. At least that's been my experience. And so the reason I mention this is that like machine learning is like hard, I think, even if you don't train the models. Like if you actually like buy this like, oh, like I'm not gonna like fine tune, I'm just gonna like use like RAG and like prompt some LLMs, you still need to do like basically all of this. Like you filter out maybe like this, you don't have the model code, but you still need to do like set up like input validation, set up like filtering logic, set up like output validation, monitor your like inputs, monitor your latency, monitor your outputs, do like back testing of your like prompts and RAG systems, do evaluation, have a trained test split so you can like experimentation, potentially like A/B test. Like there's this whole world of things, and I think maybe like the reasonable version of the like hot take is not that like fine tuning is dead, is that like if you talk to me, I will only like allow you to do fine tuning if you've done all of this first or something. Because I think it's like all of these are like higher on the like hierarchy of needs than fine tuning. Which, by the way, I think is like something that you had this like great article in O'Reilly recently that basically laid out the same thing. So I don't think it's like a super controversial take, but I think the thing that grinds my gears with fine tuning often is that people sort of like don't do any of this and then like fine tune a model before they even have like an eval, which that is I think like problematic.
Yeah, that drives me nuts too. Can you go back to the previous slide if you don't mind for 1 second?
Yes.
Okay, so this makes sense. One kind of question I have is like,
these are not very
okay,
scientific numbers, if that's your
no,
question.
but it's fine. So like the collecting data set part, okay, you don't need to do that with if you're not fine tuning.
You still
But
need some of it for your eval.
what about the looking at data?
You
Like
still
does
need
the
to do that.
looking at data, like for me, looking at data takes up to 80%. Like it's almost the same in a way. Like the cleaning and the
Yeah.
looking, it's like
Oh, totally. Yeah. To be clear, like maybe this is like not the way I should have formatted this, but this is mostly like if you think that like when you're going to do fine tuning, you're going to do like very different things. You're not. You're just going to spend most of your time looking at data. I think it's true in both. Although I think like as I mentioned, the failure mode is that people just like don't want to do this and they're like, instead I'm going to like go on a side quest to like fine tune. It's not all fine tuners,
I
but
see. Okay.
I've talked to.
Okay, so I mean you're still doing this 80% no matter what. But
Totally.
it's just
You
like
absolutely,
even more dangerous if you just go straight into fine tuning without
yeah.
like
Like the
it's
failure
even
mode in
more
my
of a foot gun. Yeah, okay.
exactly is like the failure mode is like you just like don't want to do this, and you're like instead I'm going to like do some fine tuning and like some random data set I'm not going to look at, and like do that, and I've seen that go poorly.
Makes sense.
Right. So like I think basically like most of your time should be spent on all of this, and like once you have all of this, then I think it makes sense. And then like basically the way I think about it, right? It's like this is all the stuff that's necessary to like actually have a working um, ML just like system. And so like before you even train your first model, you should have like the infrastructure to like do the fine tuning. And so it's like once you've done all of this, then I think you can sort of like consider fine tuning, but doing it before that is sort of unwise. Um, that's basically the same thing. I think like the first things I would do, I always recommend to like either my friends or like people I talk to that are building is like eval sets first, representative eval sets, large eval sets that are easy to run. Spending days working on prompts, I think like I can now not even count the number of times that I told somebody like, well, have you thought hard about your prompt? They're like, oh yeah, I've worked so hard on it. And then like I look at it and it's like in 2 hours I get it from sort of like 30% to like 98% accuracy. And I think that's like I am not a genius at this. It's just like actually spending the time, making your prompts clear, following like there's a bunch of really good prompting guides. So I'm not going to talk about it much here. We can talk about it in questions if people are curious. And like
Yeah, I think one observation here is like really interesting is like, okay, the first and the last bullet, those are like the same things that you should spend your time on, I feel like in classic ML.
yes,
Like, and so it's like really interesting, like not that much feels like it's changed in a way. Like,
totally. This is the same message we've been repeating for years.
um, but yeah, there like not that much has changed, but there is like some narrative like, hey, there's this new profession, AI engineering. Don't necessarily need to do ML or think about ML. And
Yeah.
yeah, I'm curious like what you think about that. Like,
Oh, my like okay, so my take here is that it always was the case that like you should spend your time on that and not on the sort of like like math part of things, let's say. And now it's just even clearer because like the math has been abstracted away from you for in many cases in the form of an API. If you use like API providers for models. And so like there's like a strong, I think, temptation from people that are just like interested in interesting problems. A temptation that I have and understand of like, no, like I want to like get back and like do the like fun ML stuff. And I think if that's your reason for fine tuning, it's bad. But then to the point you were talking about, once you've done all of the actual work of like machine learning, and then you've done all this and you like realize like the only way to get extra performance in this thing that's important is like fine tune or like get lower price or latency or whatever, then that makes sense. But I think like basically it's like this is the same thing that it always was, but it's almost like the gravitational pull of the fun stuff is even stronger now that it's like, oh, what, like I don't even like get to like see the Jupyter notebook, I just like have an API call. That's no fun.
yeah.
The last thing I'll say is like actually pretty important. I've left it in the last line, and like I think it's just like looking at trends and basically extrapolating on them, and either like deciding that like the trend line is going to continue or it's going to break. And I think again the real answer is like nobody knows. But if you just look at the trends of like model prices and context sizes, so this is like model price for like a roughly equivalent model, not even equivalent because models have gotten better, but this is like the like price of like a Claude Haiku slash GPT 3.5 ish level model. Um, but like the Claude Haiku today is like better than like certainly like that model was in 2021. So it's actually like even cheaper than that. The price has gone from like I think it's like $60 per mega token in 2021 to like now, if I remember well, the blended price is something like half a dollar. And context size, has gone from like I think it was 2K at the start, or maybe 4K, and now 200K, a million, 1.5 million. I think I've heard 10 million. It's possible that like both of these trend lines stop, but I think it's important to consider like what if they don't. One thing that's not pictured here is like latency, which has kind of like decreased in the same fashion. So like models are faster and faster. And it's like if in 2025 or 2026, like you have a model where it has 100 million context, it has crazy latency, and it's basically, like let's say if it keeps going, like even 10 times or 100 times cheaper, like you don't fine tune, you just throw everything in context, and these models are amazing at learning from context. And if they get faster, like you just get your response immediately. And so I think there's like a really interesting question of like, obviously you can't extrapolate, like any exponential or even like straight line forever. There's always points at which they stop. And so the question is like, depending on when this line of like price per intelligence, basically plus latency, which is very important in my opinion, like stops, then I think it tells you like, what use cases should you even consider for fine tuning? It's like you should consider the ones where it's like you're well outside of the like context window limit slash like chunking through that context at these speeds that will keep increasing will take too long for your application or something.
And then there's like the prefix caching that
Yeah,
is starting to be done.
yeah,
Do you know if
exactly.
Anthropic may offer that at
No
some
comment.
point? Okay.
This is a Emmanuel talk, not an Anthropic talk. But yeah,
No problem.
I think that like I assume, like all jokes aside, that like things like prefix caching will be like like, kind of like a common thing, certainly in a few years, right? And if that's the case, and you can imagine that your fine-tuned data set like is easy to formulate as a prefix most of the time, then yeah, that makes that equation even different. And so I think like honestly, I think this is why I had this chart last, because I think this is what started the debate. Because I think the thing that makes me the most like bullish about like, oh, we won't really need to fine-tune models as much is this chart, is like just the direction in which we're going. That combined with the other beautiful chart I showed earlier of like, like prompting growing, I think is like just a really interesting trend. And if it holds even for like a year or two longer, I think that eliminates the need for fine-tuning for many, many applications.
Yeah, there's one question from Lorian. Can fine tuning replace few shot example, especially when I need to save on tokens? I think I mean I know the answer to that, but I think like so one correlated question is like I talk with people like Harrison a lot, LangChain,
Mm-hmm.
and I'm like, oh, like what are some interesting things people are doing? And he's telling me that uh, a lot of people are doing like dynamic few shot examples. It's like think about RAG and
Yeah.
like think about like you have a database of few shot examples and you're just like pulling the most relevant ones. And he's saying like that works really well.
Yeah.
Do you see that like whoever, like the
Yeah.
people you talk to that are they doing that? Is that common?
Yes, I've seen lots of
Okay.
examples of this. This is common because like a lot of the times few shot examples become unwieldy because you want them to be like evenly distributed. So if you have like a complex use case where like your model could do 10 things, where it's like you kind of want like one example of each of the 10 things, and maybe like one example of the model like doing it one way and one example of the model doing it another way. And so it's doable, but you can just like quickly blow up your context window. And so like fetching relevant examples is something that like works really, really well and is like pretty common nowadays. I would say that like maybe in like my hierarchy of needs, there's like all the stuff we talked about, and then there's like really work on your prompt. I like tweeted something yesterday or something because I like helped the 10th person with the same loop, but it's like work on your prompt, find the examples that don't work, add them either as an example to your prompts or as like one that you can retrieve and add conditionally, and do this like 10 times. And then only after that sort of like consider anything else. That tends to work really well. Cool. Yeah, well, thanks for having me. Hopefully this was interesting to everyone.
This is very interesting. Yeah.
Cool. Awesome.
All right. Thank you.
See you, everyone.